Students, let us continue with some more concepts of the union in today's session. In the previous class when I concluded, I wrapped up with the content of array of the union variables. I just want to summarize it. When an array of union is created, you should keep in mind, even though this union has two variables x and y, but the area is allocated for only one to be held. That's why in the memory, the union that is being pointed by 0th location, first location and the second location can store either x value or y value given at a time. That's why when I print the output of the union variable at the 0th location, first location and the second location, most recent value which is there in the union will be printed. As compared to x and y is the recent value, so it will replace 2. Similarly, when I compare the union at the first position, the most recent value read is 5, it replaces 4. Similarly, at the second position, 7 will be replacing the value of 6. That's why even though I am printing the value of x and y, they are printing the most recent value that is present in the union, which is the recent one is y in all the unions. That's why it just prints 3, 5 and 7 for both the values of x and y here. Let us move to the next one. I'll just take a small example where the union is used as a part of a structure. Look here, we have a structure whose name is student. Within the student structure, I have a variable which is of type union here. Remember, since it is a union, at a given time either I can access only a name or a roll number. Since it is an union, at a given time I can access only one field, right? The memory that is allocated for union is 20 bytes because union will have the size which is equal to the field which has the largest size required. Here, to store the name I require 20 bytes, to store the integer I require 2 bytes. The largest is name. That's why to store the union I have 20 bytes space followed by integer. It's just a part of a structure. That's why it requires only 2 bytes here. Next one is, in a main program, I have created a variable of structure yes now, right? Yes consists of a union and marks as its values. Now initially I'll ask for a choice from the user whether he want to read the name or a roll number. As we know, union can either access a name or roll number given at a time. That's why I am asking the user whether he want to go with the marks entry according to the name or according to the roll number. Either of the one he can choose. If he enters N, he will go with the name. If he enters R, he will go with the roll number. That's N or R is stored in a variable choice which is of the type character. Okay, so here let us see, the user has entered R, right? The user has entered R means the user is interested in entering the student marks with respect to his roll number, right? According to the roll number, the user wants to enter the marks here. That's why I'll ask the user to enter the roll number. Then I will ask the user to enter the marks here. Okay, look here, I am accessing the member of a structure. That's why dot operator is used, yes dot roll number, right? So here I am accessing the content of a structure. That's why I am using yes dot operator followed by the marks here, right? Else part, that is, if he wishes to enter the marks of the student with respect to the name, not the roll number, then we'll go to the else part. That is, if the choice who has entered here, if it is N, then we will ask him to enter the name, then the marks, right? If he has not entered N or R, any other character if he has entered, we will just mention that you have entered a wrong choice, so enter the correct one. Look here student, the usage of union is beneficial whenever we are interested in accessing one part of the combination of the elements that are present in the union. I don't want to access all the things at all the time. I am interested in only one part, so it helps me to save the memory, because when I am using the name, I am not interested in roll number. Similarly, when I am using the roll number, I am not interested in the name. That's why it is helping me to save the memory. Instead of consuming 22 bytes of memory, it is just working with me for just the 20 bytes. Right? This is the benefit of using the union. Next, let us move to the interesting concept of pointers. Right? Look here. I am holding a pointer at my hand and I am pointing to that particular location here. What it is showing you? Right? If I click on the particular word as declare, if I click on a particular location as a memory here, means I am pointing to the location where exactly that particular word is present here. Declare is present here. Memory word is present here. Similarly, when we create any of the variables in our program, what happens is automatically freely available memory will be chosen and the data will be stored into that particular location. Let us take one example. I am declaring a integer variable x is equal to 4 and a character variable a is equal to a character q here. I have two information to be stored. One is x has to be filled with 4 and a has to be allocated the value small q here. Right? So how this particular thing will happen? Every variable has a name. Here the name is x and here the name is y. Right? When the variable is declared, a specific block of memory within the computer's allocated area will be assigned to that particular variable. Assume that we have a memory location in our computer starting with the location 1001 location 2, 3, 4, 5 till that one I have some memory location 1100 available for me, right? So when the variable x is equal to y is executed, it searches the memory where 2 byte of memory is free, because integer value requires 2 byte of information to be stored, right? So that's why it consumes, it just checks in the memory, where the 2 byte of memory location is available for me to store the value of integer. Yes, it finds out that memory location 2001 and 2 are free. That's why that particular first byte of that 4 that is present at the location 1002 will be given a reference as x and the value 4 will be stored here. Similarly, when this particular statement character a is equal to q is executed, how many bytes are required to store a character? One character requires 1 byte of memory, right? So in the memory it again searches where 1 byte of memory is available. Yes, it finds that at the 1001st location the memory is free, right? Wherever arbitrarily it chooses the place and places my variables, right? So now a is given the memory location 1100 and q is allocated to the particular area, right? The value q is stored in the location 1100. At the 1102nd location and 3rd location, we are storing the value 4 there. Okay. So when we look at this particular diagram, right? So when we look at this particular diagram, what is present? We have set of memory addresses present here, which are indicating me which variable is present at which location, right? Always the starting byte of the information to be stored is represented by the memory address, right? The value 4 starts storing its value in terms of binary from the location 1002 here. So the pointer is a variable which is capable of holding the information about the address of a variable. Look here, A variable which stores the address of another variable is called as a pointer now, right? In our memory, what is present? In our memory, we have a memory address. At some point of location, we are storing the values, right? Now, when I declare a pointer variable, what it requires is what kind of data it will be pointing, what kind of data type it will be pointing, what is its name. Okay, look here, int is a variable of type x. This particular usage of asterisk will make a variable to a pointer variable. Usage of this asterisk sign will help us to identify that it is a pointer variable, it pointing to some other information, that it is holding the address of another variable. Look here, integer x is a normal variable, x is a variable which can store the integer value. Now what is this pnum? Pnum is a pointer which can point to a integer data. It is capable of pointing to only integer data. So what is required now? As I said, a variable which stores the address of another variable. What is the another variable for me now? Another variable is a x. Now my variable pnum, which is a pointer, right, which is a pointer, it is has to hold the address of x. Pnum should hold the address of x, right? You may say x is stored in 1002 as well as 1003. Which number it is storing? Always remember, pointer will always point to the starting address, right? Starting address is 1002. So it stores the value 1002 in it, right? Remember, star is asterisk sign followed by the pointer name. Before that one, we should mention the data type. This is a syntax to declare a pointer variable. Now my pointer variable belongs to which data type? My pointer variable belongs to the data type integer, right? Means it is capable of pointing to only those variable which are of type int, right? So now what should pnum will have? Pnum will have a address of x. What is the address of x? Address of x is 1002. So I will assign the address of x to the pnum now. Remember, ampersand sign is used to get the address of a variable. So when I say when I say ampersand x, it points to the value of the memory location where that particular x is stored. The x is stored at the location 1002. So pnum is equal to ampersand, that makes pnum holds the address of x which is 1002, right? Always remember, where 1002 has the first byte of the information that is stored. First byte of the 4, integer value 4 is stored in the 1002nd location. Okay. So let us have one small example with respect to that one. Look here, I have a variable int num, that is num is a variable name which is capable of storing the integer value. Star pnum, star makes a variable as a pointer variable. Now which data type it can point to? It can point to only integer data type. What is a pointer? Pointer is a variable which holds the address of another variable. So that's why I need to assign the address of that another variable. What is that another variable? Another variable name is num. So I say pnum is equal to ampersand num. So the address of num will now be stored in the variable pnum. Okay. So I am asking the user to enter the variable. So on your screen, enter the number will be printed and you will type 10, right? So what is the value that is present at the variable num? It is 10. What address it is stored? Randomly, anyhow. Remember that whenever you are executing this program again and again, the address may be changing again and again, because randomly whichever memory is free at that time will be allocated to the will be allocated to the variable. That's why first time I have run, it might be showing me FFDC. Another time it may be showing me triple F, another number there, right? So the value present is 10, address at which num is present is FFDC. Look here, I am using one more important operator here, that is star pnum. Okay, look here, I am using star pnum. This star is called as value at address, right? Value at address. So the value that is present at the address of pnum is what? 10. Okay, so it is called as value at operator. Look here. Now I have access to the exactly the memory location where that particular number is stored, right? When I can access the particular memory location only, means I have the access to the value also, right? So look here, pnum is what now? A pointer variable pointing to whom? It is pointing to num. What is present in num? Value 10 is present in num, right? So ampersand num means what? Address of number. Star ptr, star pnum means what? Value at that particular location. Okay, look here, star num means value at that address. What is the address that is stored in the pnum? Address of num. What is present in address of num? 10 is present in the address of num. That's why this will be 10, this will be 1, and I will print 11. Remember, star is called as value at operator, ampersand is a address operator, right? You should remember them. The next one is, there are some points to be remember whenever you are using the pointers. The first one is, one pointer can point to any number of variables, but the data type should be same as that of the pointer declared. For example, look here, I have a variable x and I have two pointers p1 and p2. Both of them are belonging to the data type int, right? Now I can make p1 point to x and I am making p2 to point to x. Means to a single value x there are two pointers, p1 and p2 are pointing to same variable, right? And one more thing you should keep in mind, whenever I am using a pointer, it should point to the variable whose data type is same as that of the variable. That is, look here, look here, I have a value which is of type integer, but the pointer is of type float. What is the meaning of float star ptr? Meaning is ptr is a pointer who can point to a floating point value, but x is what now? It is an integer value. So if I make this pointer to point to x, it is invalid because content present in x is integer, while ptr is capable of pointing to only floating value. That's why it is invalid. Next one is, the variable's address may change during the different program runs. As I explained you, randomly the available memory will be allotted to the variable. So each and every run may not yield the same answer, because randomly whenever the program is run, the variables are automatically allotted the freely available area. So the address will be changing during the different runs. The second one is, a pointer variable can point to any variable as long as its data type is correct. As I explained with the previous example only, look here, I have two variables a and b. There is a one pointer. Now pnum is a pointer which is of type integer. Look here, pnum initially points to a. In the second statement it will point to the b, right? Initially it was pointing to a, next time it will be pointing to b, as long as the data types are same. This is also int, this is also int. A pointer can point to any other variable as long as the variable's data type and pointer's data types are same. Right? Let us look into some of the pointer expressions and some of the arithmetic operations that can be worked on a pointer now. Remember, what is present in a pointer variable? Pointer has a address. What is present in a pointer? It has a address. Right? Always the address is of type integer. Right? So at the maximum, address will consume 2 bytes of information. Right? It will consume 2 bytes of information. Look here, in this program, what am I doing is, we have 2 variables of type integer, n1 and n2. I have 2 variables, n1 and n2. So wherever the memory is free, n1 is allocated some particular location and 2 is stored. Similarly, wherever the memory location was free, 3 was stored. Look here, 2 and 3 are of type integer. That's why the location 1 and 2 will be used by n1. Location 4 and 5 may be used by the variable n2 here. Right? The next one is, I am initializing few more variables, some multiplication, division with some initial values. Sum and multiplications are set to 0, division is set to 1, and I have 2 pointers p1 and p2. They belong to the data type integers. Right? p1 and p2 are the pointers of type integer. That's why they can be used to point to a variable of type integer. Look here, I have 2 variables of type integer, n1 and n2, and I am making these pointers p1 and p2 point n1 and n2. How will I make? I take the variable p1 is equal to address of n1, p2 will have the address of n2. That's why p1 has the address of the beginning byte of the n1, that is 2. Similarly, p2 will have the beginning address of first byte of information that is present in n2, which is 3. Means p1 has 1001, p2 has 1002 as memory address. Remember, if I run it second time, these values will change, because at that time whatever memory is free, those number addresses will be stored here. As of now, I am using what here? I am writing a expression, sum is equal to star p1 plus star p2. What is the star operator? Remembers, star says value at operator. Star is called as value at. So value at p1 plus value at p2. Right? So value at p1 plus value at p2. So which is equal to what? Value at 1001 location plus value at 1004th location. What is present in the 1001th location? At the 1001th location I have 2. At 1004th location I have 3. So what I will do here? 2 plus 3 is equal to 5 will be printed. Right? Similarly, if we go with the next expression, which says multiplication is equal to what? Sum. Sum has 5 in it. Right? Into, look here, there is a space here. Between these 2 stars, there is a space. Means sum into, these both are together. That is star p1. Means value at p1. Right? So 5 into what is present in p1? What is present in p1? In p1 I have 1001 location. Right? So 5 into what is present in 1001th location? at 1001 location I have 2. That's why 5 into 2 will be equal to 10. 10 will be stored in the variable sum. Right? Let us move to the one more special kind of pointer, which is null. So always remember, null is a special pointer which does not point to any valid address. Right? So wherever you are accessing a memory location, right, and from that particular expression you are not getting any valid result, valid memory address is not being got, that time we require a null to be extracted. That is, look here, int pointer is equal to null. Null is a predefined constant, right? Null is a predefined constant, or we can tell pointer is equal to 0. As we know, never the memory address will be equal to 0, right? So whenever from any expression, if we are getting a invalid memory address, that time we will set it to null. So that's why null pointer is a special pointer that does not point to any value. This means that null pointer does not point to any valid memory address. Thank you, students.